All right, here's part 2 of 10.2, the notes from the other video. Um, this is really just a more specific thing of what we were just talking about the last video, but this is with FOIL, right? And so what does that stand for? Well, it's an acronym, so it means something, right? So you got first, outside, inside, last. Okay, so it's just telling you the order of which you're going to kind of look at how you're distributing it. And then it's also the sum, right? And what I was doing last time is putting plus signs between everything. And so that's just pretty much what we're going to keep doing. But the reason why this is particular is because you have to be doing this with two binomials. And a binomial, if we're going back to 10.1 with terms, is saying that two terms, and there's two of these things. So for example, right here, here's one binomial, 1, 2 terms inside of it, times a second binomial, 1, 2 inside of it, right? So there's a total of 4 terms, 2 per expression, right? Just to break it down a little further. And so the idea, though, is that you want to go in a certain order so that you can keep it in standard form. And with that in mind, it means that these expressions should already be in standard form, meaning the x's in this case would come first. If there's an x squared in one of these, it would be out front, and then a regular x would be the second term in the binomial, right? So as long as it's in descending order. So if this was 2x squared and this was 3x, that'd be in the right spot. But if this was a 3x squared, you'd want that 3x squared out front. So flip around. And then have them. If it was negative, then you'd have to have a negative 3x squared, etc., etc. I'm trying not to get too complicated here, but the whole idea is that if these are already in the right order, then if you follow the FOIL at the end, it'll already be in the right order as well for standard form. That's what we want. But how do we look at it? What does this mean? What is first? What is outside, inside, last? What does all that mean? Well, it's just telling you the order in which we're going to be distributing, as I said earlier. And we've kind of already seen this possibly. I think I even might have shown you guys this in the past. But as you can see, these are both the first terms, right? For their respective binomial. So this is the first term in the first binomial. This is the first term in the second binomial. Kind of hard to see. Sorry. First term in the first binomial, first term in the second binomial. So that's what first means. It means that's the one you want to do first when you're distributing. And then outside, meaning you stick with the first one here because it's on the outside of the whole thing. And where do you think it's going to go? Well, to the outside of the other one, this the second term of the second binomial, right? And so it's just getting the two outside terms, right? If you kind of looked at this as one whole giant thing, oh, it's getting kind of messy. Then the outside would be the 1 and the 2x in this case. That'd be the second thing you'd do. Then inside, well, probably can imagine this one's on the inside, this one's on the inside, so that's the next distribution you do. Draw a line there. And then now it's going to get really messy. Last, meaning the last term in each expression. So the 3 is the last term, it's the second term in this case, and the 1's the second term. So you do those ones last. And so if we're typing it out as we go, first, in this case, would be 2x and the 5x. Outside would be the 2x and the 1. Inside, that's going to be the 3 and that 5x. And last, it's going to be the 3 times the 1, right? I wrote it like this just to break it down better, but how you'd normally write it again would be like how we wrote it in the last video above, right? Just like this. You want to write it like this mainly. You don't have to write first, outside line, last. You just want to make sure you're doing it in that order, right? If it helps to do this at first, totally do it, right? But just remember that you're adding each of these. So maybe this will make it look a little nicer if you put plus signs between each of them. Just to remember that it should be a addition because it's the sum, right? All right, so down here, I'm just going to write it out now, though. So you got the 2x times the 5x plus the 2x times the 1 plus the 3 times the 5x plus 3 times the 1. All right, so instead of just rainbow, rainbow, like we saw here with the whole expression times each of these, we're breaking it down a little bit faster. I would say it's a little faster. Because in this case we have to do this and then we have to do it all over again, right? Down here, it's not going to be the case. It's already skipped to this line right here. So we're basically skipping the second line. We're going right to the third line of what we were doing earlier in the last video. So it's a bit faster. So then, again, just like before, you want to do number, number, variable, variable, right? If there is a variable. And then you want to combine like terms. So in this case, what are we going to see? We're going to see 10 and then x squared plus 2x, right? Because 1 times anything, it doesn't change whatever you're multiplying it by. 15x and 3, right? This is it. Just breaking it down, solving. And then you notice here, there's a 2x and a 15x. You can combine those. So the 10x squared is going to stay the same because there's no other x squareds to combine with it. Plus now 17x plus 3. And that would be it. You'd stop here. These are all equivalent to each other. That's why I'm putting those equal signs. It's just breaking it down further. Rewriting it. Okay. So then we'll just go over another couple examples here. So first, 3x and x are the first ones, so we're going to write that. 3x times x plus, because it's the sum, and then we do the outside. So 3x times negative 3 plus inside 4 times the x plus, and then you just do the last. And then that would be the 4 times the negative 3. So again, don't forget when it has a minus sign, that stays with the term after it. Write the equal sign here. And then simplify it. X squared plus negative 9 now. X stays 4x, because 4 times x is just 4x. And then the negative 12, right? Last step, again, combine any like terms you see. In this case, it should always, if it's in the right order, again, that's why I said it, it should always be in descending order. Notice how x squared, x, number, x squared, we're going to combine these x's, number. So it's pretty clean. Don't have to really rearrange things if it's already in the right order, which is nice. Less work, right? Plus, and then negative 9, 4, so it's going closer to 0. 5x, negative 12. And if I really wanted to go any further, if I just don't want to have any extra signs, right? I don't want a plus negative. I can just rewrite that as being minus signs. You don't have to do this. I'm just trying to be as thorough as possible. Right? This is the same thing as this. Either way works. Right? But having the plus signs there makes it easy to make sure you're getting the negatives right. Okay, last one down here. First, I'm going to bring it back up a little so I have more room. So you do the first ones again. So it's the first terms, n, 2n, plus, then you do the outsides, so n again, and then the negative 5, plus. Now the inside, negative 2, is 2n, plus, and the two end ones last. So you get negative 2, oh, negative 2, negative 5. All right, so again, keep that negative sign as minus, keep it with the number that's after it. So negative 2, the negative went with the 2, minus 5, the negative went with the 5. Okay, as long as you do that, you'll be good. Then combine what you can. So simplify. 2, there's no number up front, so just keep it n times n, and squared, plus negative 5n, plus negative 4n, plus negative times negative is positive, so 10. Again, there's no, most of these, since this is a specific case of two binomials, it'll always look like this. It'll always be a squared. There'll always be two things for x that you have to combine, and then there'll always be a number at the end. So it's nice to have something specific like that so you know what to look for, and you can also use it to know that you're doing it right. Because if you got some weird numbers at the end that didn't match this format, you already know you have to look back and find where that mistake was. Okay, and again, you could write this as just minus 9n, or you could write that plus negative 9. Doesn't matter. It's the same way, same answer, just written a little differently. So that's what FOIL is. Not too bad. It's a little bit quicker than this whole thing up here, right? You skip this whole step here. And it's a specific case, so you know, as long as you get familiar with it, what does the final product look like? It should always have a squared, an x, and a number. As long as you got that, you're good. All right, talk to you next time.